Okay, example 2, very similar. So again, we've got a situation where the particle is in equilibrium. That means the forces will balance in each direction. There's no acceleration happening here. And it asks us to find the magnitude of force P and the angle alpha. The only difference, right, is that instead of resolving horizontally and vertically, because we've got a slope, an inclined plane, we're going to resolve up the way of the plane, and we're going to resolve perpendicularly to the plane. Okay, so that's the only thing you have to remember. And of course, resolving is the only thing we can do in these questions. So let's start by going up the way. This is parallel to the direction of the plane with the positive direction taking us upwards. So we can see the only thing pulling us upwards is this P force, and the angle is alpha. So it's P, and then to get to that X there, we're going through the alpha, so it's going to be a cos alpha. Meanwhile, pulling us down the plane is quite clearly this force of 8, which is in the direction of downwards, so we don't have to do anything. And this 5 newtons is going to go down. It might be difficult for you to see that, but if we extend out the perpendicular direction, right, the direction there, we can certainly see that will have the effect of pulling it down. This angle is what we need to get towards to calculate that, and we can see there's a right angle triangle, 90 here, 30 here, so that would be a 60 in there. Right, so that means that we've then got a force of 5, and we're in through the 60, so it's 5 cos 60 pulling us down. Not much we can do with that because we've got 2 unknowns, so let's see if things get a little bit easier when we resolve it perpendicular to the plane as well. So, perpendicular, we can see straight away the 2 is pulling it up, but we can also see that this diagonal force of P is also going to affect it in the upwards direction perpendicular to the plane, right? It's pulling it off the plane, isn't it, as well as up the plane. So this is P, and this time we're in away from the alpha, so it's P sine alpha, and then pulling it down, the only angle we've got here is this 5 newtons. It's not going directly down in terms of perpendicular to the plane. Right, it needs to be onto this dotted line, so to move it onto that dotted line, it's away from the 60, so it's 5 sine 60. Again, that's not much use because we've got P sine alpha, so we can't solve either of those directly. What we can do is solve them simultaneously, right? If this is equation 1, we've got P cos alpha here, and we've got P sine alpha here. So if I just rearrange this to be P sine alpha equals 5 sine 60 minus 2. Of course, we can work out what that is. We can work out what that is, and we call that equation 2. Then you've got simultaneous equations. Not very standard simultaneous equations, but simultaneous equations nonetheless. And the way to solve simultaneous equations, if you've got something multiplied by sine alpha and something multiplied by cos alpha, is that you divide those equations. So if we do 2 divided by 1, we will get P sine alpha over P cos alpha on the left, and then that's equal to 5 sine 60, which I'm fully aware I could work out, but I'm just going to leave it for now. 8 plus 5 cos 60. And here's where the magic happens, right? The 2 p's are going to cancel. And the sine alpha over cos alpha, hopefully you are aware by this stage that that is tan alpha. So we've got tan alpha equals 5 sine 60 minus 2 over 8 plus 5 cos 60. So I'm going to work out what all of that is, and then I'm going to do tan inverse of it to find out alpha. And this is 12.5 degrees to 3 significant figures. Then I just have to find out what P is, and to find P I'm going to substitute that in to one of these expressions. So let's pick the first one, right, and we're going to have that P is equal to 8 plus 5 cos 60 all divided by cos 12.5, right, just by dividing the top one by cos alpha and replacing alpha by 12.5. Remember, I'm not actually going to use 12.5, I'm going to use the full accuracy that I have on my calculator from the calculation I've just done. So when I divide it by cos and then shift answer, and that should give me a really accurate answer of P, which I'll still then round to 3 significant figures, and it gives me 10.8 newtons. Okay, so that's example number 2. That's it for lesson 1. So have a go at exercise 7a. Just do the question 1 odd parts and the question 3 odds. Remember, everything is in equilibrium. All of the forces are going to balance. Resolve it vertically, resolve it horizontally if it's a normal question. If it's got a slope to it, if it's an inclined plane, resolve it up the plane and resolve it perpendicularly.